welcome you all to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. Now students, let us start today's lecture of class 9 chapter Polynomials. Now please students recall what we have discussed in my last class. What is the meaning of polynomial? Polynomial is the algebraic expressions in which polynomial is the algebraic expressions of degree 1, degree 2, degree 3, degree 4. Degree 1 is called linear polynomial, degree 2 is called quadratic polynomial, degree 3 is called cubic polynomial, where degree 4 is called biquadratic polynomials. You know students, what do you mean by degree of the polynomials? Degree of the polynomials means highest degree of the variable given. Suppose Px is a polynomial given which is equal to ax square plus bx plus c is equal to 0. This is polynomial, quadratic polynomial, because here highest degree is 2. Okay. Now let us discuss about remainder theorem and factor theorem. At first we discussed about remainder theorem. When let Px be a polynomial of any degree, polynomial of any degree when this is divided by x minus a, let x minus a be another polynomial. Please students, open your notebook and note down the important notes. When Px be a polynomial of any degree and x minus b be another polynomial, and when Px is divided by x minus a, then Pa is equal to the remainder. What is Pa? Pa is the remainder. This is called the remainder theorem. The remainder theorem says that if Px be any polynomial when divided by x minus a, then Pa is the remainder. When Px is divided by x minus a, then we get any quotient Gx plus remainder Pa. This is called the remainder theorem. Now let us discuss about what do we mean by factor theorem. The factor theorem says that you students know what do you mean by division algorithm. Division algorithm says that you know what is division algorithm. The division algorithm says that capital E, dividend is equal to divisor into quotients plus remainder. This is the very important thing. If you cannot remember this, then it is difficult for you to understand any types of divisions. It may be simple divisions, polynomial divisions, any divisions. Here let Px be any polynomial and Qx is the quotients and Dx is the divisor and R is the remainder. Then here factor theorem says that the factor theorem says that let Px be any polynomial, and Pa is equal to 0, then x minus a is a factor of Px. Vice versa, if Pa is if x minus a is a factor of P x, this shows that P A is equal to 0. Okay. This is factor theorem, and the remainder theorem says that the remainder theorem says that when P x is divided by x minus a, then P A is equal to the remainder. Now students, I have already told you only knowing theory is not sufficient. Try to practice more and more problems. I have already told you the 2.0 series will be of different level, in which I will discuss the theory in root level and will practice rigorous problems. Please students, you do your exercises. You may follow any books, NCERT, R.D. Sharma, R.S. Agrawal, any book you prefer, and ask me your doubt. Drop me in my comment box your doubt. You please students drop your doubts in my comment box. I promise you to clear all your doubts, and I have also promised to complete your syllabus and would like to solve all your doubts. Now let us discuss about some examples, which is the applications of the remainder theorem and factor theorem. The application of the, let us discuss some examples in which the application of remainder theorem, applications of remainder theorem and factor theorem. Now let us discuss some examples. Here the question says that, please students, you note down the questions and try to do your own. If any doubt persists, then open the video and see it. Otherwise, you always try to do your own. Here the question says that, here this is applications of factor theorem. Here the question says that if x is equal to 2 and x is equal to 0 are two roots of the polynomial f(x), which is equal to 2x cube minus 5x square. And it is very important students, when you try to divide, always keep the degrees of the polynomial in descending order. Then here the question says that if x equal to 2, I have already told you I will discuss all the examples, which is applications of remainder theorem and factor theorem. This example is based on application of factor theorem. Here the question says that if x equal to 2 and x equal to 0 are two roots of the polynomial f(x), which is equal to 2x cube minus 5x square plus ax plus b, then find the values of the find out the value of a and b. I have already told you students, when you get a question, try to understand what is given and what the question asks to do. Here the given thing is x equal to 2 and x equal to 0 are the two roots of the polynomials. Then according to factor theorem, as x equal to 2 is the root of the polynomial, this shows that, according to this shows that f of 2 is equal to 0. This shows that f of 2 is equal to 0. This means x minus 2 is a factor of f(x). Here x minus, according to the factor theorem, when x equal to 2 is the roots, this shows that x minus 2 is a factor of f(x). This means f of 2 is equal to 0. Then here put the value of x here 2. F of 2 is equal to 2 into 2q minus 5 into 2 square plus a into 2 plus b is equal to 0. This shows that 2q 8 2 ja 16 minus 20 plus 2a plus b is equal to 0. This shows that 2a plus b is equal to 4, one equations. Another equation says that if x is equal to 0, this means x is equal to 0 is another roots, which also shows that f of 0 is equal to 0. This means x minus 0 is a factor of fx according to factor theorem. Then let us find out f of 0. F of 0 is equal to 2 into 0 cube plus minus 2 into 0 square plus a into 0 plus b is equal to 0. This shows that b is equal to 0, and put the b is equal to 0 in equation 1. Put b is equal to 0 in equation 1, we get 2a plus 0 is equal to 4. This means 2a is equal to 4, a is equal to 2. Then by solving the equations we get the answer that here we find the answer a equal to 2, b equal to 0. This is the answer of the given questions. Here the question says that these two things are given here. X equal to 2 and x equal to 0 are two roots of the functions fx. Here fx is 2x cube minus 5x square plus ax plus b, and here the question we have asked we have to find out the value of a and b. Then according to the factor theorem, as x equal to 2 is a roots of the fx, this shows that f of 2 is equal to 0. By putting the value of x2, we get that 2a plus b is equal to 4. Then another conditions is also given here, x equal to 0 is another root. Then put the value of x 0, we get that b is 0. Then here put the value of b 0, then we get 2a equal to 4, means a equal to 2. These are the answer of the given questions. Okay, thank you. Then another questions. Then now let us discuss another examples which is based on the principle of remainder theorems. The question says that at first, students, please try to understand the language of the questions. Here I have told you, in this lecture I will discuss about two theorems and all the examples which is the based in this two theorems, remainder theorem and factor theorems. I have already told you, students, only knowing theory is not sufficient. Always try to practice, then you can find the applications of this given theory. Here we discussed about remainder theorem and factor theorem, and in these examples we will discuss about the applications of these theorems. In the previous examples we have discussed about applications of factor theorems. In these examples we will discuss about applications of remainder theorems. The applications of remainder theorems. Here the question says that find the remainder of fx when fx is given x cube minus 6x square plus 2x minus 4. Here fx is given x cube minus 6x square plus 2x minus 4, and gx is another polynomials which is given here 1 minus 2x. Then find the remainder of the question says that find the remainder. We should use here the remainder theorems. We need not to do the divisions and find out the remainders. We can apply here the remainder theorems. As gx is given 1 minus 2x, this means minus 2x plus 1. Then by solving this we get x is equal to 1 upon 2. Then x equal to 1 upon 2 is the root of the given polynomial fx. Then fx is equal to x cube, then x equal to half, then put the value of x equal to half. Then by applying the remainder theorems we can get the remainders. As we know that f of half is the remainder, f of half is the remainder according to the remainder theorems, which is equal to 1 upon 2 cube minus 6 into 1 upon 2 square plus 2 into 1 upon 2 minus 4. This shows that this is 1 upon 8 minus 6 into 1 upon 4 plus 1 minus 4. This means 2 3 ja, 2 2 ja. Here 8 is the LCM, 1 minus 12 plus 8 minus 32. Then we get this is, by solving this we get this is equal to minus 35 upon 8. This is the remainder of the given polynomials. When the polynomial fx is divided by gx, we get the remainder is minus 32 minus 35 upon 8. Here the remainder is minus 35 upon 8. This is the answer of the given questions. At first, when students you get the questions, try to understand the language of the questions. When you understand the questions, then can you solve it. Here in my previous examples, I have discussed the application of factor theorem. Here we discussed about the applications of remainder theorems. Now we discussed another examples which is also applications of remainder theorems. Now let us discuss about the applications of the another examples which is based on applications of remainder theorem. Here the question says that the polynomial is given, here, fx is equal to polynomial fx is equal to ax cube plus 3x square. This is very important, students. When you do the divisions or solve the questions, always try to put the polynomials in decreasing order of their degree. Here another polynomial px is given here, another polynomial px is given here 2x cube minus 5x plus a. Then when these are divided by gx, which is x plus 2, when fx and px is divided by gx, which is where gx is x plus 2, then if the remainder in each case same, then find the value of a. Here the condition says that when fx and px divided by gx, then in in each case we get the same remainder. We get the same remainder. Okay. Then find out, the question says that find out the value of A. Here the question says the condition is given when f(x) and p(x), f(x) is the polynomial ax square 3x square minus 13 and px the polynomial 2x cube minus 5x plus a, and when these fx and px divided by gx, where gx is given as x plus 2, in each case we get the remainder same. This means the remainder when fx is divided by gx and px is divided by gx, in both the case we get the same remainder. Now let us recall the remainder theorem. The remainder theorem says that whereas gx is equal to gx is x plus 2, this means f of minus 2 is the remainder of fx when fx is divided by gx. Then f of minus 2 is equal to a into minus 2 cube plus 3 into minus 2 whole square minus 13, which is equal to minus 8a plus 12 minus 13, which is equal to minus 8a minus 1. And in another case, when this is divided by and in another case when the gx is divided by px, then this shows that p of minus 2 is equal to 2 into minus 2 whole cube minus 5 into minus 2 plus a. This means this is minus 8 into 16 minus 16 plus 10 plus a. This is a minus 6, but according to the questions minus 8a minus 1 is equal to a minus 6, minus 8a minus 1 is equal to a minus 6, which shows that 9a is equal to minus 1 plus 6, 9a is equal to 5, a equal to 5 upon 9. Here a equal to 5 upon 9 is the answer of the questions, because here the question says that here the condition is given the polynomial fx is ax cube plus 3x square minus 13 and px is given, px is equal to 2x cube minus 5x plus a, and gx is given here x plus 2, and the question says that the condition says given here that when fx and px divided by gx, in both the cases we get the same remainder, and according to the remainder theorems, as gx, when gx is divided by fx, then f of minus 2 is the remainder. Then f of minus 2 is minus 8a minus 1. Then according to the remainder theorem, when gx is divided by px, then p of minus 2 is the remainder of the divisions. Then p of minus 2 is a minus 6. Then p of minus 2 is a minus 6, and p f of minus 2 is minus 8a minus 1, and the question is given in both the cases we get the same remainder. Then according to the questions, ATQ, according to questions, minus 8a minus 1 is equal to a minus 6. Then by solving this we get a equal to 5 upon 9. This is the answer of the given questions. Now let us discuss another examples. Another example, please students note down the questions and try to do your own. Here another example is also applications of remainder theorems. Here another example is also applications of remainder theorem. Here the condition says that if f(x) is given x fourth minus 2x cube plus 3x square minus ax plus b. Here the condition is given, f(x) is given here, this is the polynomial such that when it is divided by, when f(x) is divided by x minus 1 and x plus 1 and x plus 1, in both the cases the remainders are respectively. When f(x) is divided by x minus 1, the remainder is given, the remainder is equal to 5, and when f(x) is divided by x plus 1, the remainder is equal to 19. Then here also find the value of, find the value of a and b. Find the value of a and b. Then here the solution. Find the value of a and b and determine the remainder when f(x) is divided by x minus 2. Then at first the find the value, the question says find the value of a and b and also find the remainder, when f(x) is divided by, x minus 2. At first students try to understand the questions, what the questions ask given and what the question asks to find out. Here in the questions f(x) is given as f(x) is x to the power 4th, and it is very important when you do the divisions always keep the degree of the polynomial in descending order. Here this is in descending order, f(x) is given x fourth minus 2x cube plus 3x square minus x plus b, and the question says that when this f(x) is divided by x minus 1, the remainder is 5. When f(x) is divided by x plus 1, the remainder is 19. Here we have to find out the value of f(x), find out the remainder of f(x) when divided by x minus 2. At first we have to find out the value of a and b. Now by applying the remainder theorem, x minus 1 is divided by f(x) means f of 1 is the remainder. F of 1 is 1 minus 2 into 1 cube plus 3 into 1 square minus a into 1 plus b. According to questions this is 5. Then this means 1 minus 2 plus 3 minus a plus b is equal to 5. This means a minus b is equal to 4 minus 2, 2 minus 5. This is 4 minus 2 minus 5, which is equal to 2 minus 5 means minus 3. Then we get that a minus b is equal to, we get a minus b is minus 3, and in another questions and in another conditions f of 1. Then in another conditions when fx is divided by x plus 1, this means f of minus 1 is the remainder, f of minus 1 is minus 1 to the power 4 minus 2 into minus 1 cube plus 3 into minus 1 square minus a into minus 1 plus b. According to the questions, this is equal to 19, which is equal to 19. This means minus 1/4 means this is 1 minus 2 into minus 1 means plus 2 plus 3 plus a plus b is equal to 19, which shows that a plus b is equal to 19 minus 1 minus 2 minus 3, which is equal to 13, which is equal to 13 means a plus b is equal to 13, and another condition says a minus b is equal to minus 3, a minus b is equal to minus 3. Then by adding this we get 2a is equal to 10 means a is equal to 5. Then put the value here, 5 minus b is equal to 3, this means b is equal to 2. Then by solving this we get a equal to 5 and b equal to 2. Then here the question says find the remainder when fx is divided by x minus 2. This means we have to find out f of 2. Then put the questions here and solve this. Find f of 2 when fx is divided by x minus 2. This means we have to find out f of 2. F of 2 is the remainder. F of 2 is equal to x fourth 2 fourth minus 2 into 2 cube plus 3 into 2 square, and a is find out, we can find the value of a is 5 and minus 5 into 2 plus 2. This is 2 to the power 4th means 16 minus 16 plus 12 minus 10 plus 2. This is equal to 14 minus 10 means 4. 4 is the remainder of the f of minus 2. F of 2 is equal to 4. 4 is the remainder. Look at here, this is a minus b is equal to minus 3. This means 5 minus b is equal to minus 3. This means b is equal to 5 plus 3 is 8. B is 8 here. Then put the value is 8. This is 8. This means this is 20 minus 10, then 10. Then the remainder is 10. Then the remainder is 10. Remainder is 10. According to the, look at here students. Here the question says that here in this questions, here the question is given, fx is given x fourth minus 2x cube plus 3x square minus ax plus b. A and b are two unknown numbers here. The conditions given this, when fx is divided by x minus 1, the remainder is 5. When fx is divided by x plus 1, the remainder is 19. Then according to the remainder theorem, then when x minus 1 is divided by fx means f of 1 is the remainder. here f of 1 is equal to a minus b is equal to minus 3. Then and another conditions is given when this is f x is divided by f of x plus 1. Here the remainder is 19, means f of minus 1 is equal to 19. By solving these two equations, we get the value of a is 5 and b is 8. A is 5 and b is 8. Then another conditions is, another thing is asked here, find the remainder when f x is divided by x minus 2, and according to the remainder theorem f of 2 is the remainder for f x. Then here f of 2 is, here f of 2 is, here f of 2 is 2 fourth, f of 2 is 2 fourth minus 2 fourth, 2 fourth minus 2 fourth minus 2 into 2 cube plus 3 into 2 square minus 5 into 2, because we get the value of a is 5 and b is 8. Then by solving this we get the remainder is 10. Then this is the answer of the given questions. What is answer? The remainder is 10. Then students, please, when the question is given here, try to understand the language of the questions. When you understand the language of the questions, then can you solve the questions. And always keep in your mind all the theories. Here I discussed about the factor theorem and remainder theorem. What is factor theorem says and what is remainder theorem says. Then at first try to keep in your mind these theories and try to solve this. And I have already told you, please students, do your worksheets and ask me your doubt and drop your doubts in my comment box. I will promise you to clear your all doubts. Then today this much.